Hello and welcome to the Marketing Analytics live session. Today we answer your questions and we're going to start by thanking you for all these great questions. We have here an entire pamphlet, several different pages all stapled together with question after question after question. And Yulia and I will do our best to get through all of them. Again, we appreciate your questions. We love the interaction in this class. And we will say that the class is getting larger and larger every single time we look. It's astonishing the numbers we're getting. So we always appreciate that. And we always appreciate the warm wishes and the congratulations that we get. So let's just get started with this. So these are from, we're going to start with questions from course 2. And again, if you ever have a question, just go to the discussion forums and you'll see questions for live session and just post your question there. And we just pull them off here from time to time and we answer them. Again, if you ever have follow-up questions or questions you need answering right now, we're literally have in front of us a large monitor where we can see a chat window with all the incoming questions. And toward the end of today's broadcast, we'll be fielding some of those new questions. But for now, we'll get to your pressing questions. We've basically gone through all the questions, see which ones are the most relevant that would benefit a large audience. And we'll go over that. So can you please help me? I'm reading the questions here. Can you please help me to understand the variables for use in the calculation VIU price, please? So to do that, it's important to understand what VIU is and more importantly, why we do it. So VIU stands for value in use. Now, it's a pricing technique. It's used quite a bit for any kind of large priced item, especially in B2B, sometimes in higher priced B2C. And the idea there is it acknowledges that a lot of products need a lot of labor. You need a lot of labor. So you look at your situation. So Yulia's building is being rewired. And what's the cost of the wire? Not the installation, just the wire itself. Do you think?
I'm not sure, but I would assume it's pretty cheap.
Yeah, let's say a couple $100.
Yeah.
A couple $100, maybe $300 if they go with really heavy duty wire. And the labor is going to be
$27,000.
Yeah. So, and I would actually say in industry, you'll see that a lot where the parts are a small fraction of the overall cost. And that's what VIU actually accomplishes. It manages to fold in the cost of labor along with the cost of good. So now imagine you got some wires and they cost $600, so twice as expensive, but they only cost $100 to install. Would you buy that?
Yeah, of course. Who wouldn't?
Yeah, I'd buy that. In fact, could you give me like could you send me the link for that? We'd love to buy that. So that's the thing. So so even if that wire only costs me a couple more dollars to make, if they're much less intensive in terms of the installation process, we can charge a lot more for them. So in the back in the old days of automotive engineering, like the 1980s and 1990s, automotive manufacturers would still recommend oil change intervals of around 5,000 miles. That all ended in 2000. So in 2000 now, most modern cars, they specify synthetic oil, which costs a lot more, but it'll last you 15,000 miles. So why is that? Because the labor to do that kind of work is so much. I actually heard that on some of the newer Cadillacs, they use platinum spark plugs, which are very difficult to take in and out, but they last 100,000 miles. So you might not ever change them out. Or maybe if you do, maybe once in the car's life, maybe twice if you're a really careful driver.
Plus, depending on the industry, the cost also could include legal fees and
Mm.
license fees and association fees that also will be transferred onto the customer.
So what we have to do in that case is we'll take a look at the, we start off with looking at what's the total current cost. So to do the rewiring of your building, there's going to be the wire, maybe $300, the labor, maybe 25,000, the permit fees, like you said, the legal fees, which is probably at least $1,000 or $2,000. It's going to be a lot. Generally, there's additional fees. A lot of times for larger projects like that, they have to park a van or another vehicle in the street for a day. And to do that requires a public works permit, at least in most jurisdictions. So that's additional. There's the fee of, are they paying for, do they do anything for hotels or anything like that for residences? They give you any kind of compensation?
No.
Well, sometimes they give people their tenants compensation, but it's substantial. So you have to look at the total current cost of how people are doing it now. So that's the all the existing parts, all the existing labor of what people do now. Then what you do is you come up with a new method where something about the product makes it easier to install. So the labor is less, and what we'll find is that even though the parts, what we do, maybe cost a little more, the overall cost is less. One example is a paint called Rhino Shield. Again, this is not a commercial for Rhino Shield. It's just an example. One paint is called Rhino Shield, and instead of regular paint, which is made of latex and basically lasts about 2 or 3 years before you need to repaint it, Rhino Shield is actually made of a ceramic coating. It actually started off life in like an aerospace application. And they actually guarantee the paint, or whatever you want to call it, the coating, for 20 years, because it's literally baked on and doesn't flake off, doesn't chip off, doesn't do anything. It's made for jet engines. I mean, it's designed to last pretty much forever. I think the only real risk you incur is, what if you don't like the color? I think, was it last, like 10 years ago, it was all around like beige houses. Now it's all around gray houses. So, everyone's going to gray. So Rhino Shield does not warranty you for that. They do not warranty you changing your mind about the color. So step 1, calculate the current cost. Step 2 would then be to use that same formula, but have the lower amount of labor that your new product will incur. And then instead of a dollar value or a euro value or a drachma value for the actual price of the product, you just put in VIU as a placeholder, and then you solve for VIU, just saying that whatever. So we're going to set that whole equation to 0, and we're going to say we'll find out what's the point of indifference where the cost with the new product is the same as the total cost of the old product. And then we'll see the new product is worth a lot more. So those cables that only require a couple $100 for labor, that's worth a lot of money. If we can do that, that's worth I would pay $1,000 for cables that install themselves. That would be awesome. I would love that. And so even if we charged half that, even if we charged only $500, we'd still be money ahead. So that's the concept of VIU. That's the concept of VIU. All right, let's see. And then we asked, and then that's pretty much for the variables. So the variables are really going to be whatever your the current cost is, which is going to consist of whatever number of units you're using right now, plus the frequency that they're changed out. If it's something that lasts forever, that VIU doesn't apply to that, but nothing lasts forever. So that's pretty much irrelevant. Most things break down or wear out or need to be changed out every once in a while. I just had to do that with all the smoke detector batteries. And I wish these smoke detector batteries lasted longer. If I could actually pay more for something that actually lasts 10 years. And I actually saw that. They actually are now making new lithium batteries for smoke detectors. They're like $10 each, but they're guaranteed for 10 years.
That sounds
And
impressive.
yeah, I think I might actually get those next time. So that's a great example of value in use. Because a lot of times the smoke detectors are way up high and they're difficult to get to.
And you need the ladder.
You need to get the ladder. And if you have an apartment, you don't have a ladder, you got to get the super to give you a hand. Okay, so that's it for VIU. Question number 2. What are some common approaches to create a marketing attribution model for different channels? SEM, SEO, mobile, email, events, etc. So that's a good question. So attribution modeling and looking at different channels, it's kind of beyond the scope of this class, but one tool that I like to use whenever you have many different pieces, and usually the question I get is, well, I do a lot of SEO based on my webpage. I do a lot of SEM based on Google AdWords. I do a lot of video pull-through based on YouTube, meaning I pull in people from YouTube to my website using some display ads in the beginning or pre-rolls. So pre-rolls are those really annoying commercials at the beginning of the YouTube ads, doing pre-roll. And then what you can do is you can use a tool called Google Studio. So if you Google Studio, you'll see that tool. And what it does is it actually pulls all the Google flavored elements together and allows you to figure out which one is benefiting you the most and actually give you data on that. So Google Studio, again, I don't work for Google. It's not a recommendation or an endorsement. It's just an example. Number 3, when you are to analyze using cost per point metrics, how could you know vehicle rating value and what really does it mean? Is it given as an absolute value among all possible vehicles, or a relative value to other vehicles of interest, or a percentage of a sort of share? Speaking of the example in the lecture, I assume that one vehicle, L versus Vogue, may have various influence levels on audience in different years, so the accurate analysis seems to require accurate vehicle ratings. It would be wonderful if this point can be clarified a bit more. So good question. What this is really asking is, how do we decide which marketing vehicle or promotion vehicle is going to target our particular audience? Not all audiences, our particular audience. So in the example given in the lecture, they take a look at I think it was college employed professional women. So we don't want all women, we just want college employed professional women. So who has a percentage of that? Well, it turns out that pretty much every promotional vehicle, be it a website, magazine, print ad, e-zine, they'll all have that kind of data. Why is that? Because people want you to buy their ads. If you go to Google AdWords, they show you that information. If you go to, in this case, Elle and Vogue, I just went to Vogue.com and Elle.com and clicked where it said marketing. Sometimes it'll say marketing ads or media toolkit or media download. There'll always be a point on the website that will cater to people looking to buy ads. And when you go there, it'll give you all sorts of information. How many people read the blog or the magazine or whatever it is, the percentage of people that are employed or female or, like to do stand-up paddleboarding, why do they have this data? Because they do a lot of surveys. Do you ever get those surveys from companies?
Oh, yeah, all the time, and phone calls as well.
And then what kind of questions do they ask you?
They ask you generally how old you are. They ask you a little, mostly demographics.
Right. So how old you are, where you live. Sometimes they'll ask you about preferences, like different kind of foods you like to eat. I get all these kind of questions. Yeah, they get all these. They go crazy with the questions, and so they'll do all these surveys. They want to learn about you so that they can put out content that's relevant to what you want. And if Yulia says she's at a certain age group and that she lives in a certain location, and if she's representative of that magazine's or that e-zine's reader base, then they're really going to see, okay, what would someone like that want to read, want to view? And so they'll cater to that. And so if I'm an advertiser, I'll say, you know what, I really want to target that particular age group. So tell me how many people are in that particular age group. So that's very, very common. And the information is always free. And by the way, if you go to the website and you don't see the information you want, absolutely send that media source an email. They have probably a lot of data that, for whatever reason, they might not feel at liberty to share with the world using the World Wide Web, that they can maybe share over an email, over a telephone call, or something else like that. So I've always been impressed. Have you ever advertised or had to deal with media planners?
Not very often, no.
Well, they're very good about giving data. They're very good about, they want, just to be clear, they want to sell you ads. They want to sell advertising space. And so they're going to do whatever it takes to make you advertise with them. So they're very keen about helping. Yeah, so that's the answer to the question. The vehicle rating is given. It's given by virtually every promotion site out there. I would say LinkedIn is even better. Again, just an example, don't work for LinkedIn, not an endorsement. LinkedIn's even better. There, if you do an ad on LinkedIn, and Facebook's very similar to this, you can actually specify who you want to target. On LinkedIn, you can specify the exact title that you want to target your ad to be in. You can target the exact geographic you want your ad to be in. Facebook is very similar. You can be very, very targeted with who you want to target. And you can say, I just want to target this really, really tight niche. I don't want to pay for that. Everyone looks at it. Just the people that are really my target market. So yeah, let's see. While going through the lecture, next question. While going through the lecture 1.4 from Module 1, so Module 1, 1.4, where it explains the trial rate method of forecasting, I have a problem understanding the calculations shown in the PowerPoint slide. To calculate the trial volume when I substitute the values from the Acme dog walking service problem, my answers are not matching with the answer given in the slide. The answer calculated by me is 210 units, whereas the answer on the slide is 63 units. Can someone please help me on this? Why am I getting the calculation wrong? Okay, so you're getting the calculation wrong because you're doing the algebra wrong. So I've pulled up the slide. Unfortunately, there's no way for me to show it to you, but trust me, it's the slide that says forecasting trial rate market survey. And it shows the results of the survey, and it says number of dogs, 1.5 on average, frequency of dog grooming every 8 weeks, and so forth. And then it starts by saying, what is the trial volume? In other words, we want to know how many people do we think would try this thing? And what we'll find is that most people, if you ask them if they're going to do something, they'll say yes when they really won't. And so what we'll do is, of those people who say, I'm definitely going to buy something, we'll only count 20% of those. And the people who say 10% of those, 10% of those. And the people who say the probably will buy will count 20%. So we wound up with saying that the trial volume is a function of population, because it would have to be, right? So travel volume is always going to be a function of how many people are
Yeah,
possible. It's also a function of awareness, because if you're not aware of us, you won't know to buy it. Many people are aware of Amazon.com, so many people go there. It's also a question of availability. So if there's no units available, you can't really buy it. And then we have another part of the equation that gets into the likelihood of purchase. And then we look at a percentage of probably will buy and likely will buy. And then it's all multiplied by the units per purchase. In this case, they said people own 1.5 dogs on average. So then the total equation will be population multiplied by awareness, multiplied by availability, times the likelihood of purchase, times the units. So what this person did was they didn't notice that chunk that says the likelihood of buying. And what you need to do whenever you see a bracket around a part of an equation, whatever's in that bracket, you have to calculate first. So if you just go, I'm going to do it this way because you're watching it the opposite way. If you're going from left to right, you can't go strictly from left to right. You have to evaluate the expression in the brackets first. So there's an expression in the brackets that says we count, excuse me, we count 80% of definitely buy and 30% of probably buy. Why is that? Because not everyone who says they're going to buy actually buys. So if people say, I'm definitely going to buy it, we still only count 80% of those. And those people who say they'll probably buy it, we only count 30% of those. And then according to the survey, 10% of people said they definitely buy it, and 20% of people said they probably will buy it. So we have to evaluate that 80% times 10% definitely buy, and the 30% times 20% definitely probably buy first. So evaluate the expression first in the parentheses, and then multiply it all out. And I did this last night, and sure enough, you wind up with 63 units, just as they say. So again, it's just algebra. A lot of people have that thing. So that's how you do it. Just follow the equation. Just evaluate the expression in the brackets first. Could you expand on linear optimization model without simplifying it in cases one could apply it in real life? Thank you. So linear optimization, it's also called constraint-based maximization or minimization. It's just a great tool. It's in the 1950s and 60s, it was called operations research, which then in the 70s, they called operations management, which then in the 80s, they called linear optimization, and they called it constraint-based optimization. Now they call it all those words. Now, had you run into linear optimization before the course?
I learned it from you, but
okay, still.
But I found a good use of it ever since.
Right. And how do you use it now? If you could share that with us.
Yes, absolutely. So basically I use it for minimization purposes, but you can, as Stefan mentioned, it's often used to maximize your exposure, for example, given a certain budget, or minimize your budgets per channel, for example, or per vehicle. And so basically it allows you to find the most, it allows you to find the best combination of the resources available to get either maximum or minimum of what you're looking to get, your variable.
Right. So I always thought it was strange when people said, what's the optimal? I don't know what optimal is. I only care about maximizing things or minimizing things. So it's like what's the optimal revenue?
Yeah.
Well, there's no optimal revenue. Whatever number I give, I want more. What's the optimal cost? Well, there is no optimal cost. Whatever you state, I want less. So it's really all about maximizing revenue or views or whatever it is you're trying to maximize, or minimizing things like cost or number of trips or whatever it is you're trying to minimize. But under constraints, and the constraints are what make constraint-based maximization so powerful. Why is that? Because we live in a world of constraints. My goodness, there's so many constraints, so many laws, so many people telling you that you can't do this and you can't do that. Boss telling you got things, you have company policy, and then you have department policy, and pretty much, I don't know about you, but it seems like every 3 months, I have to watch an additional compliance video on cybersecurity and sexual harassment and violence in the workplace and this and that and this and that. And every time I do that, there's a new set of laws put in there. And wow, we've got to comply against all of those. That's hard. So we live in a very constrained, a very tight world. So in a world where we have so many constraints, we pretty much demand a tool like constraint-based programming because we need to put those constraints in there. So number one, what we'll do is we'll figure out what is it we want? What is our objective? And then that's called the objective equation. So that specifies what we want. Do we want money? Do we want happiness? What is it you want? So in most businesses, they want revenue or a proxy for revenue, which could be the number of ads or the number of views or some kind of proxy for revenue. And we'd like to maximize that. So that's good. So we have an objective equation, and that's going to consist of all of the different constituents that we have to offer, multiplied by any kind of effectiveness scores for each. What does that mean? That means we might have 5 different ways to do advertising, Facebook, YouTube, et cetera, and we'll see, well, how effective is Facebook? How effective is YouTube? Well, that's pretty easy because Facebook and YouTube will send you the bill every month in the mail or via your email, and they'll tell you how many people viewed your content. They'll tell you how many people downloaded your stuff. Why? Because they want to show you that what they're doing works for you. If they didn't think it worked, they wouldn't give you that information. But they want you to buy more, so they'll give you all the statistics on how effective it was. And you can use those statistics then in the objective equation by showing how effective each different campaign or strategy or approach is. So that's the objective equation. And then we have all the constraints equations. And usually the first one we work on is the budget equation. So you've done budget equations, right?
Mm-hmm.
It sounds like you're doing those right now.
Well, not those, but similar.
Okay.
Yeah.
And then what are you trying to minimize cost or number?
Yeah. So basically, generally, you are given the sources, right?
Okay.
And so you try to find the, as you mentioned earlier, optimal usage of each source.
Mm-hmm. Right. And so one of the ways we look at optimal usage is what do we get for it and how much does it cost us to get that? What do we get for it is, again, the data that shows us how many times a particular video has been viewed, or another indication that shows the effectiveness of that channel. And the second piece we need is how much it cost us to do that. So sometimes we'll have that as a labor cost, but I would say really more and more it's a outside agency cost, because a lot of companies now advertise with Google, they advertise with Facebook, they advertise with other channels. And what's good about those channels, I guess, is they're very good about giving you data. They're very good about explaining to you, A, what the effectiveness was, and B, how much you have to pay them for that. They're not going to forget. So you have the effectiveness scores pretty much guaranteed, and you have the budget scores pretty much guaranteed. Then the next set of constraints is going to be the capacity constraints, and that's really how many you can do. And how many can you do? Well, that's up to you. You might be constrained by your department. You might be constrained through bandwidth of your organization.
Or sometimes when it comes to like making the product, it can be how much labor you can use, or
yeah, and a lot of times if you're making a physical product, sometimes you also have a physical constraint where you can only make so many units per time period because you only have so many subcontractors who are making parts for you. So lots of different constraints. And then usually the last set of constraints are integer constraints. In general, we look at units. So the units might be the number of units that we're going to make, or the number of ad campaigns we're going to run of any particular type, or something like that. And at that point, then we don't want to say, well, we're going to run 2.3 ad campaigns. I can't run 2.3 ad campaigns. Run 2 campaigns. I can run 3. I can't run 2.3. So we can actually specify that we get that in an integer form by using the solver drop-down menu and just putting on integer. We then just put that into the format. And then the format given in the lecture is really important. You use that format because what you'll find in industry is that we really don't have, at least I've never worked at a company where we only have 2 advertising campaigns. I think one company, we had over 100.
Oh, wow. That's actually a lot.
Yeah. And well, because every single variation is a different campaign.
Yeah.
And what we'll find is that, yeah, we're going to run one ad at 2 in the afternoon, and then it might be the same ad at 6 o'clock in the evening. But as far as I'm concerned, those are 2 campaigns, because one catches the 2 o'clock crowd and the other one catches the 6 o'clock crowd. And I want to see what the difference is. I want to see where to put my money. And so I'll have lots of different variations. Google AdWords. Now you use Google AdWords. You've run Google AdWords campaigns, right? And you might have, I don't know, 10, 20, 30 campaigns.
Yeah, going. You can.
Right. So it's very common that you'll have variations and you'll have all those running. Each one of those is a separate campaign. Each one of those is a separate column in that format that we cover in the lecture. So because of that, it's important to use the methodology and the format given in the lecture, as opposed to I see most books and other courses doing where it's much more kind of loose. So this one's much more strict and allows you to scale it up much better. Much better.
And I think we have a question in the chat from Diane. Hi, Diane. Thanks for joining our live session today. And Diane is asking, when calculating the target return price, which value of unit sales do you use, given that your unit sales depends on the price that you will eventually quote?
You want to take that?
I'm not sure how I could answer that, but
So to get to Diana's point, what you'll find is that the demand curve tells us that there's a relationship between the quantity demanded and any given price and whatever that price is. So we might buy 20 units if it's $5 each, but we might buy 40 units if it's $2.50 each. So because of that, that's why we need to know in general, for range of prices around what price there is for a given number of units. So that's why I think that's what Dan is getting at, is that we're going to say, we're going to at least start that calculation with a general price for that range. One of the things that, and what we're showing in the book and also in the lecture is kind of a manual process. And that's the more traditional process. Nowadays, most of that is all computerized and done in algorithms and done much more quickly. The way that works in practice is you would actually have an algorithm where you'd say, yes, at $5 we'll buy 20, at $2.50 we'll buy 40, at maybe $10 people only buy 5 of them. So we have kind of a nonlinear curve. And we can program that into the algorithm, and we can actually find that out. But what we need then for the target, what is it here? I'm reading a question. The target return price is for a particular ROI, or target return amount. We want to specify what that is, and then we'll start off, and you're kind of converging to a price, right? So you're saying it'll be around $5, and then we see it's getting a little closer, a little closer, a little closer. In reality, the way it's done nowadays is it's all done algorithmically. One example is Amazon. You ever go to your cart on Amazon? You put something in your cart,
price changes.
and the price changes. The price changes. Why does the price change? Is it because it costs you more or less to build? No, because they're actually doing this all in real time. They know how many units sell at different prices. How do they know that? Because every single second they'll adjust the price. Sometimes I go on Amazon, and it's like watching the stock market. You look at the item, and then you look at it 2 minutes later, and the price has gone up. It's like, what is this? What is this? I can't believe this. The price went up already. And I feel like, I should sell it, or maybe if I wait, it'll come down farther. I don't know. I feel like that sometimes. So what they're doing is they're actually building a demand curve. They're getting data to see how many units people buy at differing prices. And they're using that data to then do exactly what Dan is saying, which is, find out what that price is for an optimal return. So again, we start off with a certain price that we know we forecast will sell a certain number of units, and then we start from there. What other questions do we have? Yeah. Correction. Okay, Dan. All right. I'm going to continue with this. Number 6, hello, I'm having problems executing the solver function. Is there an alternative tool? So there's different alternatives. Again, these are not endorsements. One is a product called Lingo, Lingo. Lingo, that's made by Lindo Systems, and that's available at lindosystems.com. What's nice about Lingo is once you figure out how to use it, you can calculate huge sets. So in the case of this class, we're just doing little small problems, 3 or 4, maybe 5 variables at the most. Like I said, in industry, you'll have many, many, many more variables than that. And sometimes it can kind of get tedious working with that in Solver. So what Lingo does is basically accept all the coefficients and constraints as a big matrix of coefficient values. And it allows you to solve that all at the same time. So Lingo is not free. You'd have to pay money for it, but I think they'll give you, a 30-day free trial. There's other constraint-based maximum and minimum tools out there. Again, I just used Lingo the most, as well as Solver. Anyone you'd like to recommend?
I'm sure if you know programming languages, you can just program that algorithm if that's easier for you. But I would say that Excel's solver is pretty good, and it's really easy. And even if you cannot get it to work, I would try to solve that probably.
Yeah, and again, so Solver's not doing anything magical. All we're doing is we're solving a system of simultaneous linear equations. It's Algebra 101. So for that, you can use substitution. You can use any of the algebraic techniques that people use to solve a system of linear equations. So if you Google how do you solve a system of linear equations and just follow those instructions, yeah, you can do that. In the case of the examples given in the class, there are only 2 or 3 variables. I mean, you could probably do most of these in your head. So they're not that challenging. Please discuss commonly used forecasting methods. You want to take that one? Commonly used forecasting?
Commonly used forecasting.
Or I can do it.
I don't know.
So there's time series, there's multivariate causal there's
analysis,
trial rate, and there's diffusion models.
Yes. So there's a time series forecasting method which allows us to estimate whatever it is that we're looking at for some period of time in the future. And we can do it by simply like plotting our data and doing the trend line. It's really easy.
Yeah, so in time series, all we're doing is whatever trend has happened so far, it'll continue forever. Is that right? I don't know if that's right. I mean, sometimes we're grateful when things change. I don't know. But it's good at least in the short term. For today is probably going to be a lot like tomorrow. Tomorrow won't be too radically different. What about 100 years from now? Well, 100 years from now might be quite different indeed. But so the shorter time period we look at, the more we can use time series, which is really nothing more than just an extrapolation of the trends that we see right now. So what's nice about it is it's a great sanity check. You can see if you're even close. What's bad about it is it doesn't account for change. If things do change, then you're stuck.
We could also use a regression analysis for time series, which is essentially the same thing as plotting your data and doing the trend line. The regression analysis might give us a little more accurate result. Especially if you have a lot of variables. It's definitely more accurate and better way to do it.
But Microsoft Excel will give you trend lines. It'll give you all sorts of things to help you with the time series.
Oh yeah, Stefan is right. And even in Excel, trend line will give you the actual regression equation that you can use.
I'm just saying there's lots and lots of different ways to do it. So I know some of you have had issues pulling in the data analysis toolkit on your Macs or PCs. So if you ever run into that, you can use the trendline functionality. That's part of the graphing functionality of Excel. Or as Yulia said, you could calculate it out algebraically if you wanted to. Because they're just a line, and the 2 points of the line, you can figure out the slope and the y-intercept. So it won't be that difficult. Multivariate, on the other hand, looks at not just time, but looks at other variables. So multivariate says not what's going to happen, but why. Okay, our sales are going to go up. Why? What's driving that? Is it better products, better prices? The way we promote things is better. Our distribution network is better. Our word of mouth is better, our advertising. What is driving the increase? And by studying that, we can, number one, we can find out more about why the sales are what they are. And number two, we can then simulate what it would be like if we came out with a new product. So what if we come out with a new product? How much more money would we make? If we came out with this new labor-saving technique, how much money would we save? So we can actually use multivariate to forecast, not so much in time, but in all the other variables as to what the future could be. So we could say if the future, we're going to make 2 new products and we're going to sell through 3 new stores, and we're going to do some other things, we can find out what that result would be based on those inputs. And then the problem is that multivariate requires a lot more data. And then why is that? Why does it need so much more data to do that?
It would be more accurate.
Right.
And again, as Stefan mentioned, it would give us reasons why
Yeah.
we're getting what we're getting, and how we can use it in the future.
Mhm.
But it would cost us more money and more time to do it. So
Right, because
that
we have
is
to collect
kind of
all the data.
disadvantage.
Right. So the thing is we have to collect all the data for every single possible condition. And that can be an issue. That can be an issue. I can go in here. In today's world, there are many pricing techniques available to marketers. Could you pick a few of the most efficient ones? So in the past, the easiest methods have been cost plus or versions of cost plus, like the target return method, which all they do, they just take whatever cost you incur, they add on an arbitrary percentage like 10%, 15%, 20%, and say that's the price. So that's is it efficient? Yeah, it's efficient in that it takes you 10 seconds to calculate the price, but it's not very effective because you really have not acknowledged what the marketplace wants to actually pay for something like that. It might be worth a lot more than 10%, or it might be worth a lot less than 10%. So the problems with both those two techniques is that there's no market feedback. That's why if you look at what Amazon does, which is much more of a market feedback-based approach, they look at the demand curve, or rather they build the demand curve, and then they price optimally to maximize the profits, not going too high a price, because then we won't sell many, but not too low a price either, because then we sell a lot, but we don't make that much per unit. What do you think is a good way to price things? It's a good, efficient way to price things.
I would say that the way you want to price your products or services also greatly depends on the industry you're working in and on the market you're trying to target.
Indeed.
That would be because there are some targeted markets that would be willing to pay premium price, and there are, so it greatly depends on the product and the industry and your target market, I would say. So it's kind of hard to say.
I would totally agree. And I would say in addition to that, a lot of it depends on power, the power of your company versus that of the industry. If you have a lot of power, you're what in economics we call a price maker. So Apple is a price maker. They charge $1,149 for the Apple iPhone 10. No one thought we could cross into 4 digits for the Apple iPhone 10. But they're a price maker. They charge whatever they want. And if you want an Apple, well, they're the only place to buy an Apple. So there you go. Whereas if you are a lesser company or a smaller company, you're what in economics they call a price taker. So you price in relation to what other people charge. So again, big company, you're a price maker. Other one, you're a price taker. So then you have to start looking at, how does my price compare to that of others?
Or there could be an example if you are, for example, working for a company that is just getting into business. Sometimes they would be willing to take a profit cut and do a lower price in order just to get into the market.
Right. So that's called penetration pricing. And in general, whenever you launch a new product or you launch a new business, you have one of 3 generally pricing techniques. One is market penetration. If we want to get as big a user base as we possibly can right away, we're going to price it low. On the other hand, sometimes we come out with something really, really cool. When Elon Musk came out with the first Tesla, he knew it was cool. Let's face it, it's a cool car. So he priced it over $100,000. Why? Because he could. There is no real substitute at that level of car, right? So he priced it super, super high, which allowed him to recoup a lot of his development costs. The problem with that technique is that it's got to be cool. If it's another product that's very similar to any other product, you won't get away with pricing it high, which is sometimes called creaming or skimming techniques, because people just buy something from the competition instead. And then the third way is some other way that is in generally acknowledging the power within your industry, where if you acknowledge that what you have is not unique, is not really demonstrably better than that of the competition, then you have to use like a going rate pricing, or at least price in line with the competition.
Okay, and we have just a couple more questions that we might have time to answer.
And thank you for all the questions, by the way. Okay, and I think we see some chat questions. I think that's going to be it for the chat questions, but we want to get to a couple of your additional questions that you've posted on the forum.
So we have a question. Please explain indirect competition. How can we monitor this type of competition and prepare a strategy to address indirect competition? So indirect competition generally comes from substitute products. So that would be example of a product. That would be a product that is not exactly like your product, but it somehow can fulfill the same function, basically. So what example of that could be? So for example, if we talk about the laptops, right? So there's a laptop market, and then a substitute product could be a tablet. So it can fulfill the same functions to some degree. So some of the laptop sales can be hurt by better tablet sales. So that would be an example of indirect competition. How can we monitor and prepare a strategy to address that? So it comes down to monitoring your industry and your market, pretty much. That's what I would say.
Sure, it's all about competitive intelligence. So you should have a crew that's working for you, that's continually monitoring what's going on with the competition. And ideally what you want is someone who's not just looking at your primary competitors, but other ones as well. One great example is the Apple Touch. The Apple Touch is, I think it's what kind of grew out of the Apple MP3 player series, the iPod.
Oh yeah, that's right.
Apple Touch is basically an iPhone, but without the phone. And sales are doing well. Why are sales doing well? Because the reason why sales are doing well is because Wi-Fi is available in a lot of places. A lot of people are suddenly realizing, wait a minute, I go from my house, which has Wi-Fi, to my car, which a lot of them have Wi-Fi now.
Yeah, some do.
To work, which has Wi-Fi. And then I go to the coffee shop, which has Wi-Fi. Then I go to my friend's house, which has Wi-Fi. And then I go to some public space like a park, which a lot of them have Wi-Fi now. Then I go to the airport, which has Wi-Fi. Then I go on the airplane, which has Wi-Fi. Why am I paying for a cell phone plan when I have Wi-Fi available
everywhere,
pretty much everywhere? And so what they do is you can actually buy a Wi-Fi plan. So in a world where a regular cell phone plan is like $80, you can buy a Wi-Fi only plan for $5 a month. Connect it, just hook it up with the Apple Touch, which is basically just a Apple phone without the phone. And you get, text messages, phone calls, everything. It's just done through Wi-Fi instead of through the cell phone network. And the only time it won't be a really functioning phone is if you, I don't know, maybe in the Arctic, they don't have Wi-Fi.
Yeah.
But then they probably wouldn't have cell phone signals anyway, so that wouldn't really help you that much. But that's something so right now, if I'm Apple, I'm happy. But if I'm T-Mobile, if I'm Verizon, I'm worried. And indeed they are worried, because there's not a lot of growth in the cell phone carrier industry. Not a lot of net new people getting cell phones. It's more people replacing one plan for another. So that's a concern. Then you had another question?
I
think we have time for one more.
Please explain the benefits of competitive analysis and how important is it to prioritize competitive analysis given all the other responsibilities of a typical product manager in a company? Uh, I mean, benefits of competitive analysis should be obvious, I would say. You have to know your competition in order to be in the market. You have to be compatible in order to be able to target your market and to sell your products. So benefits are obvious, but I feel like in a lot of companies, though, it is usually a separate person who takes care of that, not the product manager. If you are a product manager and you have a lot on your plate, get an assistant.
Yeah, I would say also, so I was a product manager for many years, and I would say in general, and this is a big generality, in general, a lot of product managers come from that product background. So you might start off as like a great kayaker, and then
Mhm.
you say, you know what, I'd like to be a product manager for a
Yeah.
kayaking company. And so when I ask you what the brands are, you can rattle them off the top of your head. Oh yeah, you know, I've paddled with all these kayaks. Of course, I know what they are all. So most of the times, that competitive analysis is already kind of baked into the product manager DNA. The question is not, do they know enough to interpret competitive intelligence? The question would be, do they have the time to do it? So they're using tools like Google Trends, Google Alerts are a good time-saving tool if you don't have the budget for an assistant. But like you said, for larger companies, you will often have a competitive analysis team, sometimes called the CI team, competitive intelligence.
I don't know
Do
if
we have time for one
I don't
more?
know. We have
I think
3 minutes.
we're literally
Uh,
coming up
so am
against the
I.
clock. So keep those
Sorry.
questions coming in. We
Yeah.
appreciate all of them.
Okay. The last question we're probably going to address is, please explain the basis for using R as an analytical tool and identify a few of the important functions of R used for marketing analytics. Basis for R as an analytical tool. R, first of all, is a statistical tool, I would say.
Mhm.
Correct. So anything you want to do statistically, you can execute in R, which will save you time and money as well. Few important functions of R used. We can use, I'm sure regression is widely used in R.
Mhm.
Conjoint analysis that we went over in one of our next courses. What else?
Yeah, what you'll find in R is that, yeah, it does include some extra functions, but I would actually argue that virtually any function you can find in R, someone out there has written a VBA script for that in Excel,
Yeah,
pretty
of
much.
course.
The big thing R gives you is not the functions, it's the data. So R very easily can handle multiple simultaneous data sets, which are monstrously huge. Excel really struggles with that because it was never designed to do that. Whereas what we'll find with conjoint analysis, for example, is that whereas in regression, you can do it with Excel, with conjoint, you effectively can't do it with Excel. You need the power of R. You need that ability to handle multiple simultaneous data sets.
And looks like we're almost out of time. So we do have a few unanswered questions, but we'll be happy to address those in the forums.
And thanks again for all your questions. We've gone through the vast majority of them. Again, if you ever have a question, please feel free to post them on the forum. Thank you so much for making this such an incredibly successful class. I think we're literally getting, was it 300 more students every week? I think that's the average right now. It's just crazy, crazy. 300 students every week. It's just the size of a huge, think of like a huge auditorium, more people every single week. So we thank you for making this such a great, super spectacularly successful class. And we thank all of you who make it happen. And a special one last thanks to people helping out others on the forums. Yuli and I, we really appreciate that. Not that we can't jump in and help, but what's nice is to actually create a community of you all, where you're all helping each other, that makes us feel good inside.
And that's how we know that you're learning as well. So keep it up.
All right. From all of us at UC Berkeley Extension and edX, we wish you a fantastic day and keep learning.